Hi Scanning Tim, and welcome back to Getting into Scanning. This video is going to cover scan registration and sources. When looking at scanning, the registration process is one of the most important things to consider, as this will be a significant factor in accuracies being met. As well as this, it defines how scans join to one another, and this will go on to determine how close data is to control. When looking at scan registrations, there are a couple of different types that can be used, and it must be noted that multiple types can be used in a single project to obtain higher accuracies. So let's look at the different registration processes, starting with unregistered data. This is the most basic form of data collection, and all scanners will do this by default behind the scenes. Traditionally, the scanner in the field simply collected the data at each station, and the office software was where the registration took place. Modern processes now see this registration done in the field though. For unregistered data, the scan is only aware of itself at each station. All data comes with the station 00 and relies on a registration process to create a wider picture and then georeferencing to shift the data into place. The disadvantage with this process is that it doesn't give a complete picture as to what is going on in the field, and things may be missed. And it's not until the office registration is applied that a complete picture can be seen. Cloud-based registration is the most basic of registration processes in the sense it doesn't need anything else when scanning. This process uses the cloud to register the scans to one another, identifying common elements and areas to match up against, and register the scans to one another. This process is, in one form or another, what is commonly used by field software now for registration. While quick and efficient, each registration needs to be carefully checked to make sure it has worked properly though. In difficult cases, there are manual processes to identify common areas in the scans to help with registration. Cloud-based registration is perfect for indoor scanning as well as anything where there are large vertical faces to register with one another, as this is what it uses in the primary registration process. There are some factors to be aware of with this form of registration though, particularly in relation to achieving survey-grade accuracies, which we'll cover in more detail in the next video. The next step up from cloud-based registration is target-based registration. This process relies on black and white targets or spheres to align 2-point clouds together. As it relies on common points identified in the data, it locks the two data sets together more accurately than cloud-based registration. When downloading the data, it may look like unregistered data until it passes through Office software that can perform target-based registration. It can, however, be combined with field cloud-based solutions to get an overall picture and then tightened later on using target-based registration. For those unfamiliar with spheres, essentially they are used instead of prisms in scans to identify a common point from multiple angles without needing it to be moved. When using targets or spheres in scanning, multiple targets need to be used in fixed locations, and then the scanner moves around the project area, ensuring that it picks up at least 3 in each scan. The target-based registration process then fixes the scans to one another based on the target or sphere locations. While this process can be used in georeferencing at the same time, target-based registration doesn't necessarily need to be tied to coordinates. The outcome from this is that it locks the scans to one another in known locations, fixing the locations far more accurately than cloud-based registration. While it works well indoors, it is particularly useful outdoors to achieve survey-grade accuracies. Target-based registration is perfect for outdoor scanning to tie scans together where it may be difficult using cloud-based registration. It is also great for projects requiring a tight control network. Unlike the other two processes, which can be done with the same type of scanners, station-based scanning relies on scanning total stations to perform. The reason for this is that it uses traversing and total station practices to locate the station where the scan is taken. Unlike other processes where registration is done against the cloud, this process relies on registration through the Traverse network, and as a result, Traverse network and network adjustments can affect the registration of scans. The advantage of this process is that it certainly achieves survey-grade accuracies. Along with this, georeferencing can be done as it would be done normally in the field. Another advantage of this type of scanning is the instrument is generally a total station first and has the added benefit of doing scanning. So an instrument can be out in the field every day for general survey work, as opposed to a scanner which can only be used for scanning projects. Station-based scanning is great for tying to existing survey data or projects where there may be additional survey work being undertaken at the same time. So that covers off the main three types of registration that are done with terrestrial scanners. And while there are different forms of registration seen in the marketplace, at the core, they will generally relate back to one of these processes. With these processes in mind, now it's worth understanding the limitations of some of them. Pure cloud-based scanning is not great in highly repetitive environments like tunnels and forests, as it struggles to identify common elements that it needs for registration. For the same reason, projects out in the open, with only ground to register against, aren't ideal either, which again we'll go into more detail in the next video. Targets can produce high accuracies with registration, however, there is an added time component with setting them up so they can be seen in a project. If they're being used for georeferencing, then this will slow up the field process even further. Station-based scanning is great, though generally it sees a less dense point cloud being produced at each station and is normally a little bit slower at scanning than a dedicated scanner. So it depends on the type of work being undertaken as to if this scan is the right scan for the process. For this reason, mixing scanners or registration types might be needed to ensure that the high-grade accuracies are being achieved. These aren't the only processes for producing point clouds either. For projects, sometimes a wider scope of instruments are needed to capture the data and produce the complete point cloud. Below are a couple of these, however, it is not exhaustive by any means. UAV data is probably the most common now, where the point cloud is processed from imagery captured by drones. While the process is using photogrammetry to produce the point cloud tied to GNS control points, which is generally less accurate overall than other processes, it should be by no means disregarded. LiDAR is becoming more common now too. Traditionally quite expensive and requiring planes, drone-mounted LiDAR has become quite popular and can be used extensively for different applications in producing high-quality point clouds over large distances. SLAM scanners are a new category and are widely used now for backpack, vehicle, and even drone-mounted solutions. It allows for quick capture over large distances, and the solution is improving in a quickly evolving market. Generally, it is seen as a cheaper entry-level mobile mapping solution, though producing a medium accuracy, low precision result, which is a consideration that is needed when looking at these types of scanners. It is not to say that it is wrong by any means, it is just a consideration when investigating them in terms of the data that it can be used for. Mobile laser scanners, mobile mapping solution, and MMS. These are several names for this high-end solution in the marketplace. They're generally high-end vehicle-mounted scanners producing high accuracy, high precision results. In most cases, they are very expensive solutions that capture large amounts of data from both scanning and positioning for corrections. They're great for a wide range of applications. However, at the price, they may not be necessary for an end solution. Outside of this, there's also sonar, high precision handheld scanners, and even mobile phones. The idea here is to demonstrate a wide range of devices that can produce point clouds, each with advantages and disadvantages that need to be considered for completing the picture for any project. So in this, we've considered the different type of registration processes, as well as looked at the other types of devices that will produce point clouds. The reason we've looked at this is to suggest that one type of scanner or even one type of tool for producing point clouds may not be the best solution for a project, and it's always worth thinking about what would be the best fit for the sets of tools to take on site to achieve the best result. As always, thanks for watching, and please feel free to reach out if you have any questions or want to discuss this further. Happy scanning!